Proportional reasoning starts with ratios and how to write and interpret them. So in today's discussion, we'll be looking at how to write ratios, look at ratios with units, the types of ratios we have, whether they are part-to-part or part-to-whole ratios. And then we'll introduce what we mean by dependency ratios, because dependency ratios are used as a real-world application whenever we're talking about the US Census. Ratios are all around us. We see that when we go to the grocery store. For example, when we talk about unit price, it's a ratio of the cost per one individual item. And so this allows consumers to compare prices of goods regardless of the package price, so that we can look at, for example, if we have the unit price for 3-flavor pack of cans, which has 18 cans, then the unit price becomes 56 cents per can. This helps us determine whether we want to purchase this amount of cans, or if there is another unit price for an 8-flavor pack, which has a unit price of 52 cents per can, then it makes more sense to buy this option, because this option charges less money per can. This becomes a better buy. We apply ratios whenever we go to the grocery store by looking at the cost per item to figure out which one is a better buy. A ratio is the relative comparison of two quantities, and there are various ways in which we can express ratios. We can express them using a colon, we can express them using 2 per as a fraction or as a decimal per 1. And so we can express ratios in these forms to interpret the same meaning. 12 to 15 is the same as 4/5 when reduced to its lowest term. And so we can write that as 4 to 5, express that as a fraction, and then express that as a decimal as well. We can also write the ratio in these various ways. Because the reduced fraction is still 5/4, it remains the same. And then as a decimal per 1, it becomes 1.25. Now we can compare ratios of quantities that have the same units. And so we can make a comparison between the two. So in this case, we can compare inches to feet, because we know that 1 foot is 12 inches. And so we can make that conversion here to write the reduced fraction and then the decimal per 1. We also know that an hour is 60 minutes. If we want to write this as a reduced fraction, then 1 hour to 100 minutes now becomes 60 minutes over 100 minutes. And that gives us a ratio of 3/5 when we reduce the fraction. And as a decimal, we have 0.6. And then we can do the same for the number of days as well. Is the ratio for thirds the same as 16 ninths? We talked about the fact that whatever we do to the top, we do the same to the bottom. So if we multiply the top by 3, that gives us 12 ninths, which is not the same as 16 ninths. What if we multiply both by 4? That gives us 16/12, which is not the same as 16 ninths. And we can see that in the types of movies or content that we watch, that if the ratio is 4/3 and our TV is showing the video in the ratio 16 ninths, then we end up seeing just portion of the videos where the ends of it are just black screens. In this example, we are told how much Jane earns. And so we can express that as a ratio as well. So if Jane earns $10.50 an hour and Lee earns $12, then we can express this as a fraction. So as a fraction, this becomes 7/8. And as a decimal, this is 0.875. And so we can write meaningful sentences by saying that Jane makes 7/8 of what Lee does, or for every $7 Jane makes, Lee earns or makes $8. These are the various meaningful sentences we can write. We can also compare or write ratios for quantities that do not have the same units. So if we can't convert to the other, it doesn't mean we cannot compare them. We can also compare them as we see in this example. what is the ratio of chicken to people? So we always want to pay attention to what comes first. Chicken comes first and then people second. And so we have a ratio of how many pieces of chicken divided by how many people. When we express this as a decimal, that gives us 3.25. And this is a decimal per one. In writing a meaningful sentence, we're not going to say there are 3.25 pieces of chicken per person. We'll say that there are 3.25 pieces of chicken per person. Ratios are either part to part or part to whole. Part to part ratio compares two things based on their differences. So for example, we can compare the ratio of male students to female students by comparing part to part. We can also write ratios as part to whole when we compare the ratio of male students to the total number of students. So part to whole ratio compares one thing to the entire lot or to the total. So when we also look at the ratio of female students to the total number of students, then we're looking at part to whole ratios. And part to whole ratios can be expressed as percentages. We want to determine the ratio of women to the whole class and then write the ratio as a fraction. So in doing this, we know that 16 are men, 10 are women. So the ratio of women to the whole class will be 10 over 26, which can be reduced to 5 over 13. So as a fraction, that becomes the ratio. By expressing 5 over 13 as a decimal, that gives us 0.385 when rounded to the thousandth place. We can express this as a percentage, which gives us 38.5%. We can say about 38.5% of the class are women. So if we add this percentage to the percentage of men, then the total should be 100%. When we talk about child dependency ratio, we're looking at the ratio of children divided by the working population. So those that are under 15 divided by the 15 to 64 population. When we talk about old age dependency ratio, we're looking at the oldies divided by the working population. Age dependency ratio, we're looking at the total of all the dependents. And in this case, that will be the children and then the oldies. So when we sum the number of children plus the older population and divide it by the working population, that gives us the age dependency ratio. And one thing we should keep in mind is that all dependency ratios are part-to-part ratios. And for part-to-part ratios, we don't express them as percentages. If we have part-to-whole ratios, that is what we express as percentages. The higher the dependency ratio, the larger the number of dependents relative to the number of working age people. So what that means is that we have more people to depend on someone for support. And so when we have a lower dependency ratio, we have the working age people being large relative to the number of dependents. So we always want that to be the case, and that is the more desirable economic approach. We want to make sure that there are more working people in the economy than there are dependents.